In this program, I have a 5 kilogram cylinder. It's initially at rest, okay, and it's touching the wall here at B and this roller here at point C, or rotor, okay. The coefficient of kinetic friction as this thing rotates is 0.2 at each of those surfaces, okay. If this guy is rotating with a constant angular velocity of 6 radians per second, I want to determine the initial angular acceleration of the cylinder. Okay, so knowing that this guy starts off at a constant velocity of 6 radians per second, okay, what's the acceleration of the cylinder? Start with a free body diagram, as I typically do. I've got 2 normal forces, 2 frictions, shown here. Okay, we assume it's sliding, giving me the kinetic friction, so it's 0.2 times each of the normal forces, both at the wall and at the rotor. And the other force I've got, of course, is the weight due to gravity. So that's 5 times 9.8. Okay, so this guy's going to be in pure rotation about the center, which I have labeled O right here. Okay, so I'm going to apply my equations of motion. Okay, again, I guess before I do that, I'm going to find the moment of inertia about point O, which is not only the center of gravity, but it's also the point of pure rotation. So either way is the point that I'm going to sum my moments about. Those are my only 2 choices. Okay, so I have 1/2 mr squared. Okay, because this is a disk. Look up its mass moment of inertia. It's going to be 1/2 mr squared. Plugging that in, I get I about both the center of gravity and the point of pure rotation, which is the same point here shown there. So now I'll sum my forces in the x direction. Okay, so I've got NB, I've got negative NA sine 45 and positive 0.2 NA sine 45. That's what I've got there. Sum my forces in the y direction. Okay, I've got 0.2 NB up. I've got 0.2 NA sine 45 up. 0.2, not 0.2, just NA cosine 45 up, and then the weight acting down, which is 5 times 9.8 acting down. So those are the sum of the forces in the x and the y. Then I'm going to sum the moments about point O, which is also point G. Those are the only 2 points that I can sum my moments about, either a point of pure rotation or the center of gravity. Here it's the same point, so we're all good. So some of the moments about that, really all I have are my frictions, both of which are a radius away, which is 0.125. Okay, they go in opposite directions, but all other forces go right through the center there. So I've got the 2 frictions, and then I've got the alpha shown here. I alpha shown here. So from the top 2 equations, I do some of the, the 2 equations, 2 unknowns. I can solve for NA and NB from the top 2 equations. Taking those 2 equations, plug them into this equation, I can find alpha is 14.2 seconds. So really, free body diagram, sum of the forces in 2 directions, set them equal to the mass times the acceleration in each direction. And then I can sum the moments either about the point of pure rotation or the center of gravity. In this case, it's the same point, so I don't need to worry about it.